Good morning, folks. This recording is for Pre-Algebra Chapter 9, Lesson 3, Classifying Polygons. So a polygon is a closed plane figure with at least 3 sides. A polygon can have more than 3 sides, but can't have less than 3 sides. If it only has 2 sides, then we would just call it an angle. But we're not dealing with angles today. We're dealing with polygons, which means that they have closed figures. So like this. Hey, there's a polygon. There's another polygon. There is another polygon. Polygons, right? So, polygons are again closed figures that meet at their endpoints. A triangle is a polygon with 3 sides, and we classify triangles by angle measurements and side lengths. All right. So, and we also use tick marks to show congruent sides of a figure. And remember, congruent means that the lengths are the same. So here are some triangles. Remember that acute is less than 90 degrees, right is exactly 90 degrees, and obtuse is greater than 90 but less than 180. So if we're talking about an acute triangle, it means that all 3 angles are acute. If it's acute, all 3 angles are acute, because you can have acute angles in other types of triangles, but an acute triangle specifically has 3 acute angles. All right, so there they are. Actually, there they not are. There they are. Okay, then a right triangle has a 1 right angle in it. You can only, and when you're dealing with triangles, you can only have a triangle that has only 1 right angle. And that's because all of the angles in a triangle have to add up to 180 degrees. You have to be able to fold them all down and get a straight line. Okay, so a right triangle has 1 right angle. An obtuse angle has 1 obtuse angle. So again, the only time that you're going to have exactly 3 acute angles is in an acute triangle. Everything else will have at least 1 angle that is more than an acute angle. All right, and then again, here are the tick marks, which is kind of hard to read my writing, but that's a tick mark. Tick marks show that the sides are equal. So when we're talking about classifying triangles by their side lengths, we talk about how long they are and if they are the same length as other sides of the triangle. So an equilateral triangle has all 3 sides that are the same. An isosceles triangle has 2 congruent sides, and an isosceles scalene triangle has all 3 sides being different. So notice how the tick marks change. So on an equilateral triangle, all 3 have the same tick marks, which means all 3 sides are the same length. On an isosceles triangle, 2 of the sides have the same number of tick marks, and 1 side has a different number of tick marks. That means it's isosceles because 2 of the sides are the same, which you can usually tell by the number of tick marks. If 1 side has the same number of tick marks as the other side, those 2 sides are the same length. And in a scalene triangle, all of the sides are different, so we have no congruent sides, which means none of them have the same number of tick marks. All right, so again, congruent means same length. All right, so let's go ahead and talk about naming these triangles. A scalene right triangle means that all 3 sides are different lengths and it has 1 right triangle. That means you can classify triangles based on their length and lengths of sides and the angles present inside the triangle. So we need to make sure we cover all of our bases. It's not just a right triangle, it's a scalene right triangle. All right. Part B is a scalene obtuse triangle because it has 2 sides that are the same length, as we can tell from those tick marks, and we have 1 obtuse angle. So therefore it's a scalene obtuse. All right. Now part number C is a scalene obtuse because all 3 sides are different and it has an obtuse angle. Dropped my stylus. Okay, so quadrilaterals. Quadrilaterals have 4 sides. Triangle, 3 sides, quadrilateral, 4 sides, because tri means 3, quad means 4. Now the most basic quadrilateral we have is called a quadrilateral, and it just basically has 4 sides. There's nothing else special about it. It doesn't have right angles, it doesn't have parallel sides, it doesn't have congruent sides. All the sides are different, which I can tell you by these tick marks, and none of them are parallel. All right. Also, so from there we have a trapezoid, and a trapezoid has only 1 pair of parallel lines, and we can show parallel lines just by writing it out. But yeah, there we go. We have parallel lines, and 2 of them are the 2 sides are parallel. So this side is parallel to this side, but as you can tell, this side and this side are not parallel. Eventually they'll meet if they continue off in their directions, whereas these blue lines here will never meet. All right? And then after that, we have a parallelogram. Now, as you can see, this is kind of a flow chart, which means trapezoids are like quadrilaterals in that they have 4 sides, but trapezoids are more specific because they have 1 pair of parallel sides. A parallelogram, on the other hand, like a quadrilateral that has 4 sides, has 2 pairs of parallel sides. Both pairs are parallel. So this side is parallel to this side, and this side is parallel to that side. So that's why we have both pairs of opposite sides are parallel. And opposites are the ones that are across from each other. The orange lines are across from each other, and the blue lines are across from each other. Now after that, we get even more specific, a rectangle and a rhombus. A rhombus has 4 congruent sides, and the opposite sides are parallel, because a rhombus has the same characteristics as a parallelogram with 1 extra thing going on, the fact that all of the sides are congruent. All right, there we go. So a rhombus not only has both sides parallel, but 4 congruent sides. A rectangle, on the other hand, is very much like a parallelogram in that it has 4 parallel sides, the opposite sides are parallel, but they also have 4 right angles. All right, but this length and this length are the same, and this length and this length are the same, but unlike a rhombus, they're not all the same length. All right, now last up we have a square. A square is the most specific thing we can have. Not only does it have 4 sides, like a quadrilateral, but it has its opposite sides parallel, and like a rhombus, it has parallel like a parallelogram, and like a parallelogram, and it has 4 congruent sides like a rhombus, and like a rectangle, it has 4 right angles. Okay, so again, basically we start at the least specific thing, that's a quadrilateral, it just has 4 sides. Then we move into 1 pair of parallel sides, which is a trapezoid, and then we move into a parallelogram, which has both pairs of opposite sides parallel. And then we differentiate between congruency, which is the rhombus, and the 4 right angles, that's the rectangle, and then we move on to squares. Okay, there we go. Crazy diagram. Okay, so let's go ahead and name the types of quadrilaterals that have both pairs of opposite sides parallel. Well, that's actually quite a bit of them. That would be a parallelogram, because they have opposite sides, and then everything else that's more specific after a parallelogram. That would be a rectangle, a rhombus, and a square. So there's actually 4 things that have opposite sides parallel. Again, a parallelogram, a rhombus, a rectangle, and a square. All right, next question. Name the types of quadrilaterals that have 4 right angles. Well, there's only 2 of them. The only 2 that have 4 right angles are rectangles and squares. All right? And then how we name quadrilaterals. Well, normally a quadrilateral will have letters by that, like A, B, C, D. And we just start at one vertex and one vertex, and the plural of vertex is vertices, and then we just go around. So we go from A to B, C, D, and back to A. So that would be quadrilateral A, B, C, D. All right? And sometimes we can name them fun things like any normal middle school appropriate 4-letter words. Okay? All right, so what is next? Next would be other polygons. We have regular polygons. Regular polygons all have the same side lengths. They're all congruent. So let's go ahead and talk about that. Let's just get rid of all this. Let's just go cut. Come on. Cut. Cut. And cut. So again, regular polygons all have the same length. So if I have a regular triangle, it means all the sides are the same length. If I have a regular quadrilateral, I have a square because all of the sides need to be the same length. But I could also, I guess, have a rhombus or a square. And then I have a regular pentagon. And just assume that my pentagon is regular. So that's a pentagon. And, oh, this is a triangle. All right, and then we also have hexagons, which I'm horrible at drawing, but they're 6-sided figures. And again, they all have the same side lengths. The other thing, though, that's important about regular, and again, we're talking about regular polygons, is that all of their angle measurements are exactly the same. So all of the angle measurements on a triangle are the same. On a rhombus or a square, they are all the same. On a pentagon, they are all the same. And we can use angle measurements just like tick marks and say that, all right, this angle measurement is the same as all the other ones that have 2 angle measurements. Whereas, here with this triangle, if I only have 1 set, then they match all the other ones that have 1 set. Okay? Alrighty. That, I believe, is it other than perimeter. Just know that when you're solving for perimeter, you have to add up all the sides. So if I told you that I wanted you to find the perimeter of a regular pentagon, and I told you 1, 2, 3, 4, 5, regular pentagon, and I told you one side length was 5, and you know that a pentagon has 5 sides, well, you do 5 sides times the length of that side, and you'd get the perimeter, which is 25, whatever units it is, okay? All right, I'm done, guys. Bye.